This is the third video of my Desmos Masterclass course, and today we'll be going over advanced math. Here's what we'll cover today: systems of equations, inequalities, absolute value graphs, and nonlinear functions. Let's jump in. To begin, let's cover systems of equations. Systems of equations can deal with two or more equations, and you have to find the solution to the system. Let's look at this example. 2x plus 3y equals 6, and x minus y equals 4. We can solve this by first plugging in both equations into Desmos, and then on the graph you can look at where they intersect. Additionally, you can see systems where one or more of the equations is nonlinear. It could be a quadratic, cubic, or even quartic, but we can still solve this the same way by plugging into Desmos and seeing where they intersect. Next, let's cover inequalities. Inequalities are basically systems of equations, except instead of one possible solution, they can have many. For example, y is greater than or equal to negative 2x plus 2, and y is less than 0.5x minus 1. You can solve this the same way by plugging it into Desmos. However, you have to look at where the shaded regions overlap, and that is the region where all the solutions would work. Note, when dealing with inequalities, the dashed line means the less than symbol, while the solid line means the less than and equal to line. So if you see that there are solutions that are on the dashed line, then that would not be a right equation. Now let's cover absolute value graphs. Absolute value graphs are basically parabolas, except instead of a curve, there are two opposite linear lines joined together at the vertex. We can see this example in many equations represented by the two bars. Now let's look at this hard absolute value question from College Board. First thing we do is we can plug it into Desmos, and you can either use the math.absolute function in Desmos or the two bars on your keyboard in order to create an absolute value function. Then, as we remember from our last video, we can replace the equal sign with the tilde, and we don't really need to replace the s with anything because it's a constant by itself, but if you really want, you can replace s with x1, but just know that it's a constant. You also need to say that the initial condition that s is less than 0, and then we get our answer. Lastly, nonlinear functions are basically functions that are not straight lines, and these can be anything from parabolas to circles. Questions you may frequently see are going to ask you to identify information on the graph, such as x or y intercepts, or even ask you to apply transformations, all of which are skills learned from this video and the past two videos on this channel. That concludes the third video of this Desmos Masterclass series. In the next video, we'll be going more in depth into advanced math in order to show how Desmos can be used to solve any type of question from advanced math.